All right, so I think we'll get started. Welcome to this last Munch and Learn for the year. Today we have I have with me, and for that talk, two Jeff and a Francois. They'll be talking about Redfish, the past, the present, and the future. Before we actually get started with the interesting part of the talk, let me quickly get you through a few house items about the Munch and Learn. We started this type of talks and technology talks this year in 21. We run 11 of them. We missed October, I think. We will continue to do those in 2022, and we have already a session that is planned for January 19th about, we don't have a title for it, a definitive title, but we know it's going to be NVIDIA and HP Esmeralda together, and we'll come up with that title pretty soon. And we will update our Munch and Learn calendar page, which is, you can see here on the, we'll also cut and paste these links in the chat. So keep the chat window open. We'll dump all these links for you. On that page, we maintain the calendar of events, and also we maintain the registration link for these sessions. And also we provide replay links of these sessions that we record and store on YouTube a few, let's say, days when everything goes right after the event. So keep an eye on that page. You'll get the link there if you were not able to follow that session. The other thing that we do, and it's called Munch and Learn because it's a different time everywhere on the planet, and we have people from all over the world, is we try to make this fun. And we have a dedicated Slack channel on our Slack workspace that you can find here and register here. And we have that Slack channel where you can, I have to admit, it's easier with a phone. And if you have Slack on your phone, that's very easy. But we share what are our munchies. So if you want to play with us, just show a picture of what you're having for your munchie and dump it into the Slack channel. It's fun. Also, if you're more like a Twitter person, you can use a tweet and you can tag it with HP Dev. So we recognize those funny tweets. So you can see some people's here over the last year had different things depending on time of their day. And that's all really I wanted to say. If you are interested in joining the HP developer community, which we are managing, you can scan that code and you'll find yourself directed to a URL which has all the links you might want to need. For example, our Twitter account, our Slack channel, our web, of course, and many of the other things that we provide, such as workshops on demand and other technology talks. So feel free to capture those links. And with that being said, guys, it's all yours. And I will stop sharing my screen and provide it for you.
Great. Thank you very much. Quick round of introductions real quick. We've got a number of us on the session today. My name is Jeff Hilland. I'm working in the CTO's office in the Advanced Development Group for infrastructure manageability and have been for quite a while. I'm also president of the DMTF, which is the founding body that standardizes Redfish. Jeff, you want to introduce yourself?
Yeah, and I'm the other Jeff. I'm Jeff Autor, also a distinguished technologist in the CTO office. Like Jeff, I'm also involved with the DMTF. In my role, I'm actually the co-chair of the Redfish Forum, which is the working group within the DMTF that owns the Redfish specification.
Francois?
Okay, thank you. My name is Francois Donzé. You can see that I'm French and I'm a technical consultant working for HP for a long time and focusing on low-level management. And I will have a pleasure to make some technical demo after the presentation here. Thanks.
Thank you, everybody. So what is Redfish and where did it come from? I hope you're on this call because you're at least a little bit familiar with Redfish. Really what it is an industry standard software-defined management for converged hybrid IT, and that's kind of a mouthful. What we ended up with is something that's HTTPS with JSON formatted payloads based on OData v4. The intent was to make it schema backed but human readable, where it could be equally used by either an application or by a human. We wanted it to be extensible, secure, and interoperable. And the initial focus was really on, in 2015, was on servers, but we started a whole lot longer ago than that. We wanted to do a secure multi-node replacement for IPMI over LAN for a number of issues, and we'll get into those in just a second. We knew we had to represent the full category of servers at the time, whether it was rack mount blades, HPC, even future technologies. We wanted one thing that was going to last at least a decade, because it's really hard to change your management infrastructure once you've standardized on an API. OCP was getting started at about the time we went public with Redfish, and so we wanted to make sure we met all of their requirements, and we made some really good inroads into OCP as far as getting support for Redfish and most of the DMTF standards as a whole. All along, we wanted to expand the scope of Redfish. We knew if we did it right, we would be able to standardize on server management, but the entire infrastructure isn't just servers. It's also storage and networking and power and cooling and buildings and cameras and all the rest of it. And so we wanted to create an infrastructure that could expand its scope over time. So we release about 3 or 4 times a year, depending, but we wanted to expand that scope. And so we've got a bunch of alliance partners, and we'll talk about those in a minute. But key ones really were SNIA, which created a parallel name called Swordfish, and that one does storage management. But also them are us. The people that participate in SNIA is really most of the people that are participating in Redfish, at least a cross section. And that's doing storage, network storage type of management. And then we're working with Green Grid and AshRay to cover facilities, and that's DSIM, and Jeff may talk about that here in a little bit. And then as far as fabrics, we're working with Gen Z and CXL and the Ethernet folks to try and get fabrics covered as well. But Redfish really got its roots around about 11 years ago, maybe 12 years ago. We were working on Matrix 2.0, and we created this converged infrastructure architecture. And Matrix later became OneView. And so we created this common HP RESTful protocol called CHIRP, C-H-R-P. And that was kind of the basis for the RESTful protocol. We started kicking the tires on a 3-layered architecture. We have an application on top and resource managers in the middle, and then the managed devices down in the bottom layer. And so I started contacting the iLO team about, hey, we're thinking about doing a RESTful protocol and make it schema backed. And I approached Mike Garrett, and my boss is Keith McAuliffe, and he was like, well, Jeff Autor's doing the same thing. He's looking at IPMI and going, yeah, they want to turn it into XML, and this is horrible. And, there's no interoperability. Jeff, meet Jeff. And Jeff at the time worked over in Proliant land on the iLO team. And so the 3 of us, Mike Garrett and Jeff Autor and myself, got together and started kicking the tires on us. Like, I had all these schema ideas. It's like, no, the schema should look like this. And Mike Garrett was, man, I can't tell what schema is this, that, what's it actually going to look like on the wire. So Mike Garrett set up this Nginx server in a lab and set it up to do JSON payloads, and gave me the ability to just do mock-up dummy data of what the JSON payload would look like. And so, we started looking at what RibCL would offer for data coming out of iLO. And then we kind of realized, wait a minute, iLO has this GUI already where it's doing, web services, it's doing HTTP, HTTPS, it's already got JSON data, let's just use JavaScript data so iLO can actually use the stuff that's in Redfish for its web GUI. And so we started looking at the data over there too. And eventually we started developing the data model, some things that we had thought about earlier, like separation of the manager from the server and creating those separate objects and creating the chassis separately. Those were things I'm in Austin and those guys were in Houston. I made a couple of trips down to Houston where we were doing some whiteboard sessions on, well, this doesn't work and this doesn't work. Bladed chassis would be different, and where does a manager sit in it? And so, we started combining both that chalk talk we would do with each other with mock-ups on the server. And then we started looking for a schema language that actually met our needs. What we didn't realize during that, and again, this was happening in, I don't know, started 11 years ago. And so while Redfish really only came out, 6 years ago, we were working on it for a good 5 years before it went public, or at least the basis of it. And as we started developing, things on this won't work, we started writing down the architectural principles, which I'll show you on the next slide. So we really did develop them over a number of years. And some of this was through customer feedback as well. What don't you like about RibCL? We'd taken dipped our toe into WS-Man a little bit, and why that didn't work for us, but it worked for other people. And so we started learning the lessons from everything we'd learned before. And we came up with a number of principles. We had, all along, I thought, let's just keep this HPE proprietary. I was full in, let's just do, get one view to do this, and I'm a standards person. I've been doing standards since '96. And this was like the first one where I'm like, yeah, maybe it doesn't make sense to make it a standard. And Jeff, wisely so, convinced me that we should probably take this to the DMTF. And even then I was VP of technology for the DMTF. And yet, I'm sitting there watching SIM, which was basically what WMI is based on. If you're familiar with Windows WMI, it's based on the Common Information Model, which also came out of the DMTF. And we started talking about making it RESTful. And we had this cloud API, and we had SIM, and those guys were talking, and they couldn't agree on what RESTful was. And so I was just like, there is no way the industry is going to agree on what RESTful semantics are, period. And Jeff, I don't know, beat me up enough to says, no, we got to take this and make it a standard. And so the thing inside of HPE was, it was, Chirp and Riz. Maybe Riz kind of made it out the door. If you remember the initial versions of Redfish, that was rich infrastructure services, where we had this view of, gee, the same piece of software, whether it's inside the OS or outside the OS, should be able to tweak the system on the fly and optimize for whatever workload you're running. And that was kind of one of the genesis of the things we were trying to do. And hey, that's great. And Jeff was like, no, we got to take it to the industry. So we sat down and created this list of people we would probably partner with and who to take it to, and then some weighted options on what's the impact if we take it here, what's the impact if we take it there. We were looking for a name, and Jeff kept calling it Redfish. I didn't really care for the Redfish name all that much. I wanted to call it some other things, which I'm not going to say what they are, because they were much worse. But Jeff, you want to tell them where you came up with the name Redfish?
Well, it was enough. First we just needed a code name, so it was really the internal code name for it, and we always have something, something for it. And my thing with the time was that I was sick and tired of 4-letter acronyms for everything. There's a big company, that's kind of where it happens, right? So the Redfish name came from just as a code name, over time, as the marketing folks tried to actually come up with a real name for the specification, they tried, and we actually had settled on something. And it never, they weren't able to get a trademark clearance to be able to use those. So, we basically told them at the event, you couldn't, if you can't come up with anything better, we're just going to call it Redfish. And besides, by the time they got to that, the name had already been well established with so many developers that it stuck. But the code name came from a reference to a restaurant, because in my previous experiences, there were successful industry standards that were named after the restaurant near the campus of it was actually, I think, Intel in California, that the one that I was referencing of El Torito, which was a bootable CD-ROM spec back in the early 90s, and that was work that was done by a bunch of companies, and they basically met at the El Torito restaurant. So that's where they picked the name of the spec as a code name, and it stuck, and everyone called it that. So that's what the name of the spec was. So the Redfish Seafood Grill is an excellent sushi restaurant very near the HP campus here in Houston, and it was also a cute and short and easy to pronounce name. So that's what I picked as a code name, and then it stuck. So What we didn't know at the time was the fact that the Redfish name also then has a you can see the Redfish logo, which obviously is very red. But years later, when we're all presenting this stuff at industry conferences, you see how between the fish and the color, it really stuck out because everybody else was using blues and greens at the time. So we were the only one using a big red logo. So I'm sure it's not the case anymore, but it was a happy coincidence.
Well, the case in point, the one I remember was we approached these industry partners, and we ended up, you can go back and look who it was. It was Avocent and Intel and Dell and us, and we spent about a year developing the standard before we took it to the DMTF, and then we did a release at IDF. And as Jeff said, Diane Bryant's keynote, and this was what, December of 2014, I guess. I guess it was August 2014. Anyway, there's just all these green and blue logos on there, and this big red fish sitting up there, and it was just, how could you miss it? It was just, so it was one of those things where the DMTF, we went and tried to rename it, look at other names. It was just, this name is stuck. We changed the logo a little bit. It used to be a round fish. Now it's something a little more geometric, which I guess at the time, met the DMTF's requirements.
Well, the logo was actually done by a firm that was hired by a DMTF to create the logo. So, but it was actually based on an earlier logo that had that binary fish kind of motif going on. But the one that was had just been contributed by one of our folks is just amateur artist a bit. But it was a fish, but it actually wasn't a redfish. Redfish could be one of 4 fish species, it turns out. So, but it didn't look like any of those. So they kind of restylized it, and then but kept that binary fish scale pattern. So that's kind of where it came from.
Yeah, the original redfish looked more like a goldfish to me than a redfish. But anyway, we're sitting there in the booth. Intel had given us some space to talk about redfish, and it just was crowded like mad. And we did some panel discussions and things like that. And we were really surprised by the amount of attention we got. So I don't know if it was what we were attempting to do, which was standardized server management, at least start there. Or if it was just that big red logo sitting up there in the middle of a field of green and white. We ended up getting a lot of attention, and had a whole bunch of people ended up joining and helping us with the effort once we took it to the DMTF. And that was really what got us to finally write down the architectural principles, these design tenets that Redfish is based on. We really wanted to represent and leverage the common internet web standards at the time. If you did a internet search, and you asked what's the most popular HTTP payload, XML was losing and JSON was winning. And if you're trying to do some kind of API, well, REST was the nomenclature of the day, and so that's what we picked. We knew it had to be flexible for modern hardware designs, where we could do a standalone scale out or silicon or the OCP designs, but we need to make it simple. And that was that lesson that really I learned from Mike Garrett, which was you don't need to have a PhD to use this stuff. You should be able to read the payload for most of it. Now there's some complex operations in there as you're trying to represent the full functionality of the machine that you're going to have to understand the semantics of the hardware underneath it, because we weren't trying to change the hardware. We were just trying to let you see all the knobs and controls of that machine and be able to manipulate them. And that early design tenet of, okay, let's separate the protocol from the data model, turned out to be one of the really important things we did, because it doesn't matter if I'm going over HTTP and using REST, or if I'm using some other technology. We need to be able to change that over time. Now, while it's based on CRUD semantics, create, read, update, and delete, those are kind of the 4 operations you do. And there's action, which is, gee, I need one thing to push the easy button because I don't want to do true REST, representative, where I manage the state of a power reset, where I keep hitting and changing the power state. That's an awful way to get a customer to reboot his system. So instead, give them an action to do it with. So we weren't quite strict with REST, but by separating that protocol from the data model, it allowed us to adopt other schema languages. There's no reason you really couldn't do Redfish in XML, but it was 3 times the amount of a body because of the way XML is written. And then we knew we could get a common hardware denominator because everybody had a web server in their BMC. So they already needed, with that web server, and because they were doing a GUI, they needed JavaScript and they needed HTTPS. So we knew we could build it based on those building blocks, but we also needed to change it over time. And so where you really invest your code in isn't the wrapping and unwrapping of the data. It's not sending it over a transport. Transports come and go. Look at the way your web browser is built, right? There's HTTP, HTTPS. We could put something else in there. And then the payloads, well, they may be JSON, they may be hypertext, they may be PHP. There's all these other ways of doing it. But where you invest is the data itself. And so we tried to make that data itself be transportable based on multiple schema languages. So when OpenAPI came along, it was easy to do that. We started with both CSDL, which was the OData stuff, which OData wasn't actually in the original Redfish. We kind of got co-opted into that as part of the standard. And it's what it takes to get a standard out the door, but the original Redfish didn't have any of the $OData ID or OData.type. The original ID was just called URI, and all our links were just called URI, or and the original type was just called type. So it's funny what happened to it over time, but that was just a mapping. It was the data. Okay, type. I can change that into and out of my code on its way into and out of the system. And that was the fundamental design tenet. Let's separate that data model, the code itself that you're going to be manipulating inside of your program, from the wrapping and unwrapping, marshalling and unmarshalling of the data across any given protocol. And that was a fundamental design tenet, which we've taken advantage of in a couple of ways. The protocol suite, again, that we were trying to do at the time, we knew we had to do SSL. It had to be secure, secure enough for your bank account. SSDP was the discovery protocol we used at the time, because IPMI was using ping sweep, and that was, often looked like a virus attack inside of a data center. Something that starts hitting every port of every server out there. So we didn't want to replicate that. We use SSDP because that's the way printers were discovered. And we figured if it was small enough to fit in a printer, you could do it on any server out there, any UPS or PDU, or the smaller components that you have in the infrastructure. We wanted to match the modern tool chain. Again, that's why we did REST and JSON. And then that data model, we wanted to make it schema backed, start with CSDL and JSON schema, and then when OpenAPI and others come along, we could map to them. So really that easy to use data model that a human can just read in most cases. In fact, when Jeff was doing the power and cooling, Jeff, you want to tell that of the person reading the, what was it?
Yeah, it was the power supply. So, we were starting to do some of the power infrastructure pieces. And so as part of that, and what drives a lot of the work is making sure that we have subject matter experts to tell us what what data is needed and what should it look like. But this whole easy to use thing, and I don't need to have much training to look at the JSON payload, and make heads or tails of it. Like if you know what that data means, well, part number is called part number, serial number is called serial number. So very quickly you should be able to get an awful lot of data. You should be able to figure out what an awful lot of it means. You start getting into RAID, storage configurations, and if you don't know anything about RAID, well, yeah, at some point you're going to have to go pick up a YouTube video or a document or something, right? But yeah, the example was I was talking with the power supply team, and so these are not these are electrical engineers, they're power systems engineers, they are not computer people, so not programmers, I guess would be the better way. And so I'm looking for feedback. Is like, hey, what other information about the power supply do you guys need to be able to do your jobs? What data needs to be presented? And so as I'm sort of talking through this, and I just showed an example of the payload, just put up a slide that just had, here's what a theoretical power supply looks like, and you see like part number, serial number, voltage input, voltage output, et cetera, et cetera. And and as I'm talking, there's the guys are kind of looking at this and they're seeing this for the first time, and they don't know anything about JSON, they don't know anything about REST. And one of the guys says like, finally kind of like shakes his head and interrupts me and says, like, the data doesn't make any sense. And I'm kind of dumbfounded because wait a minute, what do you mean it doesn't make any sense? It's voltage and current. I mean, the words up there all, how does that not make sense to you? Explain. And he said, like, well, but you've got like your reactive current at this and this, and and he starts doing the math and telling me that those numbers don't make sense. I'm like, I just made up the numbers. I didn't even bother doing the arithmetic, and don't ask me to start actually doing the cosines and whatnot to get all the no, that's just made up numbers. I just put them there so you knew that was a number, not a string. And but I realized, like, wait a minute, you not only were able to figure out from zero knowledge 5 minutes ago that not only were you able to comprehend the data, but it was so easy for you to comprehend that you're able to see that it was complete garbage in terms of the numbers. So that was a great confirmation that we were on the right path in terms of ease of use for folks that were experts in the data, and they didn't have to have much in the way of overhead to understand what it was we were what we were transporting.
And that was the design tenet, right? Was trying to make it as easy to use as we can. Is everything easy to use, as he pointed out? No, it's not. In fact, there's some parts of it we would like to redo. There's some parts of it we're in the process of redoing. And so that gets me kind of into Redfish scope today. Look, it all started with just servers. And in fact, the original RIS did more than what IPMI did, but as part of the negotiation, to get the industry along with us, we had to narrow that scope down to, like, let's just start with what IPMI does, and then we'll expand the scope from there if we were successful, and we were. So we've been expanding that scope ever since. There's a project that we did with more people on, let's do storage and let's do NIC and let's do NVDIMMs and get them in, and BIOS and firmware update. And we started working on the side together, and it just became so complicated, we just went straight to the DMTF to finish the work. And then we started working with SNIA on network attached storage. And that was where Swordfish came from. And the first Swordfish iteration, I don't think it met the ease of use requirement as easy to use as most of Redfish. So we went in and we really kind of recast things. And when we did NVMe, particularly NVMe OF, we took hundreds, I think it was like 79 IOs to set up an initiator to a target in the original Swordfish, and we got it down to 3 in the unoptimized case and 1 in the optimized case. So again, that we try and pay attention to the ease of use of a lot of this. Then came fabrics, as you look at a system, and we started to, inside the host bus, we're starting to open all that up and crack that open with Gen Z and CXL. And then of course, Ethernet and PCI. So the original fabrics work started with Ethernet and PCI. The telco guys looked at what we had and said, hey, that's really good. It works, but what telco does real well is some of the, switch to switch manipulation. What they don't do real well is some of the policy language kind of stuff. And your overall fabric topology looks a lot like a policy language to us. So we've been working with the telco folks and some of the aggregator folks to do that as well. And there's open source work on aggregators. And what I mean by an aggregator is, imagine there's a bunch of ILOs out there, also, or could be any vendor's Redfish server, as long as it's speaking Redfish. Or maybe even then, it doesn't have to speak Redfish. It could speak something else. And there's a plugin to support that. And so let's take all these disparate resources from the data center or from a rack and put it in one interface so that I can manage things at scale. And that's what aggregation is when we brought that in. So if you look at ODIM in the Linux Foundation, OpenRMC to a certain extent in OCP, some of that is being done. The DSIM work, data center infrastructure management, when it comes to power and cooling. You've got servers and you've got storage, and boy, anything made out of a server is, well, you've got the servery bits, the fan and the CPU and the memory and the workload and all that, you're missing my component there. So that was kind of where fabrics came from. And then DSIM, well, if it's small enough to fit in a BMC, Moore's law kind of caught up with us, where now it can fit in a PDU or a UPS. So, well, what about the crack units and everything else, and software defined outlet groups, which kind of blew my mind, but that's all in there. And it's certainly being developed. And then we started working our way up the food chain a little bit with composability. And so we ended up with 3 different kinds of composability. I call them, little c, middle C, and big C. But, intentional resource by resource, I'm hand constructing either a VM or a true composable system, or I'm just trying to set boundaries on it. I'm doing constraints. I'm, give me at least 2 CPUs and at least, 4 gigabytes of memory or something. And then a manifest-driven API is the latest thing that came out of Redfish, where it really is, I need a bunch of systems because I'm putting together a cluster or some kind of workload, and I need 4 systems of this. Just go make it happen and tell me what they look like when you're done. And set up some of the network components potentially as well in there. So that's the work that's gone there. And this was the first standard I'd been a part of where we didn't have to go hunt people down to help us with these efforts. Instead, they were coming out of all over the park, contacting either the DMTF or our member companies directly. And that's what the list of DMTF Alliance partners is on the right. You can go to the DMTF webpage and look at the work registers that lays out all of the work. They're doing this and we're doing that. Let's not make this stuff not work. Let's make sure it dovetails together and works really consistently, because we don't need 2 different standards that do the same thing. We don't need you to do a Redfish definition or your own, definition on how to do that. And so working with Gen Z and NVMe and the Open Compute Project, and real interesting work going on with the Open Fabric Alliance, where they're over there trying to create a universal fabric manager that speaks Redfish out the top and talks to either a Gen Z or CXL or Ethernet-based fabric out the bottom, and you've got one fabric manager. Particularly in an HPC case, the high performance computing guys, they need the ability to preserve that code that's on the northbound that manages that infrastructure, and just make it happen on the bottom side. And so, that's where some of that comes across. PICMIG was an interesting one. So was the Open Group, because the Open Group, they had a group together that was working on industrial supply, like petroleum production, or large-scale industrial machine complexes where their fat pipes are measured in meters, not megabytes per second, because they're pushing liquids through these things. But they're trying to reconstruct their systems based on industry standard components now. And they looked at Redfish and they said, wow, you've got sensors, you've got CPUs, you've got memory, you've got systems, you've got VMs. What you don't have is the operating systems and workloads represented. And we were just trying to do IT infrastructure down at the hardware level. And they're like, no, we need to know the OS and the workload and manage it. We need to know what the Kubernetes workload is. I thought it was weird, you want to represent a Kubernetes workload in Redfish, but that's what they wanted to do. And so they've submitted that to the DMTF as well. So we've kind of gone all up and down the food chain here as far as what you consider infrastructure in where Redfish scope is and where it's going. One of the things we needed to do is replace the host interface. When you look at what the BMC traditionally talked to inside the operating system, it was this PIO, for those of you who go back that far, byte at a time interface where you'd shove 1 byte down to the BMC and get a byte back. And that just didn't work. We're trying to do, K or megabytes or firmware images in a standard way, not everybody doing their own way. And so we needed a way to replace the interface that surfaced to the host operating system. And what we decided to do was just create a NIC. Just create a virtual NIC on the BMC, expose it to the host OS. Yeah, it won't work for everybody, but it sure beats what we've got. What it allows you to do is preserve all your code that's created for working on your management plane and just run it on your host OS. So the way I manage my system and talk to my BMC, I get to use the same code, the same libraries, the same everything. And so that was the thought there. We wanted to make it kernel mode and user mode accessible. We realized there were some security concerns, and then again, just getting people used to it and comfortable with it has probably been the biggest hurdle. We had some technical hurdles. It's like, how does UEFI use this? And some of the pre-boot stuff that really only matters to us systems integrators, as long as we do it right. But we think we've overcome most of those challenges now. So anything that can access the host out of band can be run on the host OS, if you have the account and the privileges to do it. interoperability profiles were an interesting one. In order to get the standard through, pretty much everything was optional, right? And that makes sense from a systems integrator standpoint. I can't guarantee on this system from the BMC that I can measure how much memory is on it. I may not be able to, so I can't make memory required. I may not be able to see what the CPUs are, or maybe my implementation, maybe I could do it, but I've chosen not to. So as we started going through some of the information about a system, we really couldn't put anything required. And so our way of dealing with that was to create interoperability profiles. So this was a machine readable profile definition done in JSON that describes, okay, this object is required, this schema is required, you got to have these, you've got to have so many of these properties, if you have this, there's conditional properties in there. And so it became a way of saying, taking it's kind of the opposite of a line item veto. It's a line item inclusion, please include these, and include all these properties. Yes, if you have fans, I want a fans array in there. Or now it'd be a cooling collection. I want to see those objects in there, and I want to see processors. And so if you're a 1U rack mount server, here's my 1U rack mount server profile. And then we used the industry to go through and create conformance tools that can then read that machine readable profile into a conformance tester, make sure you comply to that profile, and then spit out the results in a human readable format. What tests did you pass? Which ones did you fail? And it also has a way of generating human readable documentation, because the machine readable profiles in JSON, it's a little bit gnarly to go through, but the fact that you can create a requirements document and take that to a vendor or a customer or whatever, or another standards body, and say, this is what you need to do. Oh, okay, I can read all that. It's human readable. It really is helpful. So and profiles can be created by either DevOps personnel and non-computer science. You don't have to be a computer science geek to go in and read these profiles. Once you get the hang of it, I think it took me about 20 minutes to figure out how to write one. So it's not like it's rocket science. And we've gotten other partner organizations to develop the profiles, particularly OCP is a good example there, where they're in there defining, what does a 1U server look like? Well, how do you manage that 1U server? Since we're able to define the components that are required in it, they were able to define what a profile should look like and get everybody to adhere to it. And then, of course, all these tools are open source. They're out there on the internet for anyone to use. Which gets me to the next subject, known open source efforts in support of Redfish. I'm really only going to talk about the industry standard ones because many companies have their own. We're going to have the demo of the iLorest tool here in a minute. That's an example of one, but the DMTF creates a large suite of validation software so that folks can test their implementation, test their protocol, test use cases even, and make sure that the products conform. But there's also tackle boxes and other tools out there. There's RESTful tools that you can use to go out and do fixed function. Like you want to do a firmware update, there's a little firmware update tool in the tackle box. There's yeah, it's a little fishy, the whole tackle box thing, but the point is to try and make it easy to remember that if you want to update your server or reboot it, there's little commandlets out there that you can download and they'll work, and they've been tested. We have this interoperability test bed that has servers in there from multiple vendors that we can then use these test tools on to make sure that they're interoperable and work on multiple platforms. In fact, we've got contractors in the DMTF that are creating the open source to do that. And that's kind of where the vertical integrations came from for OpenStack and Ansible and Puppet, was we got the contractors to go and develop some of that, as well as the validation suite. So, most of us at our day job, we don't get paid for writing code. We get paid for driving the industry and don't have the bandwidth to do this kind of stuff. So it was nice to be able to collect dues from the industry and then amortize the cost of the development of that open source across the industry, so that not one single company had to suffer the burden of it. That didn't stop any of our companies from then writing their own RESTful tools, and OneView is working on talking to Redfish, and so it's good to create your own support suite for it, but it isn't actually required. I think the iLorest tool is probably one of the better tools out there, but Oh, thanks for posting the link to the GitHub. DMTF is out there. Now, SNIA has some tools for Swordfish. It turns out they work for Redfish because Swordfish is worked on based on Redfish. But anytime you start classes going into their classes for, storage subsystems and things like that, well, if you don't have a storage subsystem, those tools aren't going to work. So keep that in mind. And then ODIM, I talked about that. That's the aggregator that's out there. That's a part of the Linux Foundation. A shameless plug here for some of the other work you'll never see, but it's kind of important to understand why we did it. Inside the box, there's all kinds of signals going on that's in the manageability plane that ILO talks to, all these I2C signals that go to every device, all the sensors and that kind of thing. And then we also piggyback data on PCI using PCI VDM to get information for PCI devices. There's I3C, there's CXL, there's all these interfaces inside the box. And we want to take that data from those devices and get them over to ILO to get them out the box. What we've heard from customers is, but every time you do that, you have a firmware dependency between that component and that component in that ILO. And if I change one to fix a bug, now something breaks on the other. So what we did was we created a provider architecture inside that's based on these protocols called MCTP and PMCI. And I'm not going to go into the alphabet soup, but we're basically taking a Redfish definition. Remember how I said it was important to standardize on the data model? We turn that into that JSON into a binary definition. And so all these components out there that support RDE, Redfish Device Enablement, and we're working with the storage vendors and the network vendors and all that to do that, they actually host all of the data themselves, all of the NIC data, all of the storage data, all the disk drive data, all the information about that, creating volumes, they host it. ILO doesn't have to know anything about it. ILO just takes this RESTful protocol that comes in, translates it into this RDE thing, it goes over the manageability interface, the device eats it, figures out what the request was, figures out, oh, you want me to create a volume? Fine, I'm creating a volume, sends the data back over to ILO. ILO just chunks it and changes the binary data back into JSON and spits it out the wire. What that allows us to do is change out the components, the NICs, change the firmware on them, and we haven't broken any manageability interfaces. I can do a firmware update from ILO on that thing and not break the manageability interface. So that was a really important architectural piece. And so we've leveraged the DMTF to create firmware update pieces and the security protocol and data model so I can make sure I'm talking to something secure, and RDE so I can have a provider out there on that component and provide a richer infrastructure management experience from ILO and through the aggregators and through the rest of the architecture. And we need that for HPE as much as our customers need it. So it works both. And you can actually find presentations out there through SNIA where I go into gory detail on how RDE works. But it works for all kinds of devices out there where the BMC just acts as a broker to get data to and from the client. More is coming in Redfish in 2022. I hate to these are things that HPE certainly wants to see. I don't know what the rest of the industry wants to see, but we want to complete the CXL mapping because as CXL comes out, we know that's important. Security administration has a focus because the security administrator is going to be a little bit different than everybody else out there than your standard admin or read-only client or someone who just wants to reboot the machine. I really want to go see, are all my devices trusted? And so it's important for HPE to focus on that. Metrics and telemetry and logs and debug and everything that helps us reduce the cost as well as helps customers figure out what's wrong. And then the completion of DSIM, the power and cooling and management of the rest of the control and power and cooling inside the infrastructures, things we're working on as well. And the Redfish forum, it's open. We've got a whole bunch of people in there that are both promoters and supporters. Jeff, do you remember how many there are now? It's like 16 promoters and 20 supporters.
It's around 30 companies all told, and the number grows, but it shrinks more due to mergers and acquisitions than folks leaving for any other reason. So yeah, it's around 30. But I mean, if you look at the list, it's a who's who of the IT industry. So everyone between Google and Meta and IBM, HPE, Dell, Intel, Vertiv, Eaton, kind of all over those, any big company you should see their logo on the list.
Quick shameless plug for redfish.dmtf.org. The HP side is certainly important. There's a number of resources out there. There's the schema definitions. There's the bunch of profiles. There's mock-ups on what servers could look like from other vendors. The educational aspects are to me the biggest value besides the schema index and the schema guide. So schema guide is all the schema definitions put in one document. Real easy to read and certainly helps. But there's also the Redfish user forum. You can see a picture of it down there in the lower right-hand part of your screen, where you can go out there and we curate this forum on a weekly basis. You can ask a question and we'll answer it if it's part of the standard. Now, if it's a unique problem that's unique to a vendor, we might point you to that vendor. But if it's a problem with Redfish in general, or if there's something you want to see added to it, the best way for us to get that through, even into just ILO, is ILO now wants anything we do in to be standard. They want to be part of standard Redfish before they put it in. Now, there's some things we'll never be able to do that with, where there's value add, or maybe the industry doesn't want our way of doing it or whatever. But pretty much everything else, we are trying to make it standard and standard Redfish and get it into the schema definitions. So feel free to post things out there on that Redfish specification forum. And then, look out there for YouTube videos. We've got a YouTube channel on how we do this kind of stuff. So with that, I'd like to turn it over to Francois for a demo on the iLorest tool.
Did you want me to launch the quick poll about this, who's using Redfish, just to find out from the audience?
Sure, yeah, please.
Thanks, I'll do that.
Yeah, one of the things we really like to get is feedback on, what you're using in Redfish. Are you using it today? And then, what you want to see in it. And so the Redfish forum is a great way to find out what you want to see in it. So Francois, anytime you want to take over sharing.
Okay, let me unmute. So I share my screen here. Then, so thank you, Jeff. What I'm going to do here is present very rapidly this iLorest tool. Okay, iLorest is kind of proprietary, although the sources are on GitHub. It's a Python-based Redfish client tool, and the trend actually is to make it work on several Redfish implementation, not just only HP ILO-based implementation, right? So here, the first thing I want to show is a remote interactive mode of iLorest here. But the first thing is, who am I on this computer here? We will understand why. So I am Francois on the Linux system here, and the interactive mode starts just by typing the executable name. I have this message saying basically that if I am non-administrator, only remote mode is available. Remote mode means that I will need to supply an IP address, a username, and a password. If I am administrator or root on a Linux system, I can access directly without any IP address through a specific channel on ILO-only systems, and without supplying any username and password. We will understand why this can be interesting here. So in interactive mode, if you type the beginning of a command and then tab, we have this command completion mode here. And this is the help for iLorest here. I'm not going to go into in the detail of all those commands, just describe briefly the two types of commands. We have what I call atomic commands or micro commands: guess, get, set, logging, commit, whatever. So those atomic commands are in contrast to what I call macro commands, like clear pmem pending configs, which is a set of several get and set commands, atomic commands. So we have macro commands for persistent memory subsystem. We have some raw commands. I will describe that in a minute. Smart array macro commands, iLor commands, so dedicated to iLor only, and some others here. So as I am a dumb user on this system, first thing I have to do is to log in, providing a user a remote IP address, which is iLor 5 here, a username and a password. Okay, it takes a while, and then I get this message discovering data, 3 dots here, and then done. Actually, iLorest is using a cache, a local cache. So it retrieved a lot of information from the remote Redfish implementation service, and put them in a cache locally here. Then, as Jeff mentioned, one of the pillars of Redfish is that each and every property belongs to a data type, to a resource type. So before retrieving information of anything, you must select, you must know from which data type belongs the data you want to get or set. So if you are, for human beings, the easiest way is to go to actually the online documentation. I put the yeah, if somebody could put the address in the chat here. So what I would like to do for this example here is to retrieve the IPv4 addresses that I have in my system, and from this documentation, I can learn that IPv4 addresses belongs to the Ethernet interface type here. So the first thing to do is to select the Ethernet interface phase. I don't need to put the version number, just a dot to select a right version number. Just verify that I have the right, I selected the right type. Okay, my type is selected. Selecting the type, finding the type is maybe the most difficult thing that you have to do when you want to retrieve or to get or set get or set properties here. And this is an example of what I can do with iLorest. So what I want to do is to retrieve IPv4 addresses not from all of the interfaces I have in my system, but only from one, which is the manager virtual network interface. So this is the host interface that Jeff described. We call it in the iLor the virtual NIC, or manager virtual network interface. So remember this address here. We will use it a little bit later here. So then a best practice when you are using Redfish clients is when you are finished, you should log out here and exit from the tool to go to the next examples here. So remember a little bit the IP address 16.1.15.1. And the next mode I'm going to describe is the scripting mode. Let me change the prompt here. Remote script mode here. So And to prove that the trend is to have iLorest agnostic from the Redfish implementation, I am right now logging into an open BMC system with the username root and a password here. It takes some more time, although this open BMC is on the same VLAN here, the same private LAN here, and we can see we have more than 3 dots, just because iLorest could distinguish that this is not an HPE ILO-based server, and it's faster with HPE ILO-based servers compared to other vendors here. Anyway, if I take a look, so this is scripting mode. So each time I want to get or set some things, I need to call again the executable here. So if I make a type, if I want to list all the types I have in this open BMC here, but I forgot to do that on ILO previously, but anyway, these are all the types I have on open BMC. You can see that none of them are starting with prefix HPE. All of them are standard Redfish, DMTF standard Redfish types here. An ILO5 Redfish implementation has some types with prefix HPE, which are, of course, specific to HPE, and this is where we can put our added value here. So there is a type called manager here. So let me select this type. iLorest, I need, this is script mode. and retrieve some information from this open BMC here. This command shows that, remember previously, I did retrieve the IPv4 address with a filter. Here I am retrieving 2 things at the same time using the same a single get operation, and the output is in JSON format. Okay, so this is what we can do with iLorest here. Another very interesting thing is to use the save utility, and I want to save all the parameters from the BIOS data type and from the manager data type. By default, everything goes into this file. It's possible to redirect the output to another file. So now if I do more of this file, I have the ILO version, well, which is not actually, this is the OpenBMC firmware version I have here. This is needed because this output in this file can be used after that, after modification, if you want, with the load command, so you can re-inject those parameters into multiple other and the same kind of BMCs remotely, typically with the load command. And if you want to have more help, if you want to know about the load command, just do iLorest help load and read the output here. There is the -m switch here with some multiple file names here. Actually, this is almost the end of the presentation. We have one, yes, so only 1 minute to go. I thought my demo was only 5 minutes, but it takes more of this. So contact me on my email francois.donzi@hp.com, or go to Slack and ask questions here. So I can continue the demo if you wish here. So I will stop here. So Didier, you can make the wrap up here. No problem. And sorry for this long demo. I have to stop here.
Thank you, Francois. I've started the poll. You can give us a hint about how useful that was for your work. Francois is indeed answering a lot of questions in our Slack workspace, both on iLorest. There's a channel for iLorest, and there's another one for Redfish. So feel free to join the Slack channel and go see his answers. And I also put a note in the chat about the fact that we have some workshops on demand. One of them, built by Francois and some other colleagues, is about programming Redfish. And you can take those workshops any time of the day or night. It's available 24/7. It's free. It's available on the internet. So if you also need to convince some partners or customers, you can do that. The experience we use to deliver those is through a Jupyter notebook and some bash command like Francois just showed, or PowerShell or bash, depending on which module you use. So feel free to give our workshops on demand a try. Thanks for answering the poll. And with that, I would like to wish you a great holiday period. Thank you again, Jeff and Francois. And thank you everyone for joining. We'll talk to you in 2022.